Okay, let's go ahead and get started. Hello and welcome to the 2026 Water Matters webinar. I'm Annalisa Vinolia and I am a I'm a communication specialist too with SCV Water. Today's session will be recorded and posted on our website by the end of the week. The presentation will be about 45 minutes with about 15 minutes of Q&A. If you want to submit a question, please use the Q&A function, as I said in the chat. We'll be answering questions at the very end of tonight's presentation, so if you send them during the presentation, we're not ignoring you, we're just holding it till the end. And if you have any questions or concerns after tonight's presentation, please email us at waterquality@scvwa.org. I'll drop that in the chat, and we'll go ahead and get started now. Jenny, take it away.
Great. Thank you so much. Thank you everyone for joining while we explore the 2026 Consumer Confidence Report and water quality in the Santa Clarita Valley. My name is Jenny Anderson and I'm a Senior Water Quality Specialist at SCV Water. So our overview today, we're going to be discussing a little bit about who we are, water quality monitoring and analysis, how we tackle PFAS contamination, regulatory compliance and reporting, common water quality calls, and then some Q&A at the end. So we are a full-service water agency located in the Santa Clarita Valley. We were formed on January 1st, 2018 by an act of the state legislator, SB 634. We provide water service to 197 square miles, over 75,000 service connections, and nearly 300,000 people. For water quality monitoring, we really use a lot of abbreviations. We use abbreviations all the time, and here are a few of the more commonly used abbreviations that we use specifically for like water quality parameters. So for example, DBPs, or disinfectant byproducts, those are formed when a disinfectant like chlorine or chloramine interacts with the natural organic material that is found in water, and it can create TTHMs, or total trihalomethanes, or HAA5s, haloacidic acids. And some ways we, as an agency, reduce those DBPs in the system would be to shorten the contact time or the water detention time within the distribution system, or to reduce the chlorine concentration in the distribution system. So here are some pictures of sample stations that are throughout our entire distribution system. You may have seen them, you may have driven by them, you may have walked by them and didn't really know what they were. They're actually a great way for us to monitor our entire system from all branches of our system to really see real lifetime water quality data. And it actually really helps us. So when we look at that data, we can then use that to effectively chlorinate our tanks if and when necessary. And when we're looking at chlorinating, we want to make sure we have a good chlorine residual within our system. So we're looking between a 0.2 and a 4.0 milligrams per liter, and that's per the EPA. So we have a total of 88 sample stations, and we collect 72 samples every single week for total chloroform that also include temperature and chlorine. And then we collect 27 general physical samples weekly that include pH, color, odor, and turbidity. The sample stations are on a rotating sample schedule, so some sample stations are sampled more frequently than others within that given month. We have 108 tanks that are sampled weekly and then dosed with chlorine or a chloramine if there's a low chlorine in there, or if there's a potential for nitrification. And just to kind of go over a chloramine, that's actually a 5-to-1 chlorine to ammonia ratio, and it's actually a really good disinfectant. It's a little bit stronger than chlorine, and it has a longer lasting residual, and it has a lower odor. So it's very effective when chlorinating. So source water monitoring, we receive our raw surface water from Castaic Lake, and that feeds into our 2 treated surface water plants. We have our Jerry Gladbeck, which is right near Central Park, and then we have our Earl Schmidt, which is near Castaic Lake, and then we have our groundwater wells, and you can see all the pictures right here. So in groundwater, monitoring is unique to every individual well, and it's based on concentrations within that well. And so certain wells may have increased monitoring for constituent that others do not. If you see in this graph right here, weekly we have PFAS and perchlorate, but also on quarterly, we have perchlorate and PFAS. So it's very site dependent on that frequency of that monitoring. And then our Division of Drinking Water, or DDW, they also provide us a vulnerability assessment. And that again is site dependent per that well. And that will tell us per the permits which wells need to be sampled for what constituents and that frequency. And then similarly, we have our surface water treatment plants. They also have different monitoring requirements depending on the source of the water. So for our surface water treatment plant, there's extensive monitoring that occurs as often as every 4 hours, but then there's other constituents that are analyzed annually. So water analysis. If we're looking at analytical chemistry, the science of identifying a substance and how much are present in a sample. So we want to look at qualitative. What is it? It may seem simple, but if you were walking down the street with a bag of a white powdery substance and a cop pulled you over, it would be really important to know what is that white material that you're holding. Is it baking soda or is it something illegal? That cop is really going to want to know, and you're probably going to want to know as well. Quantitative, how much is there? If you were interested in purchasing a gold bar, would you like to know if it was gold plated? If it wasn't, you would want to know the purity of the gold. Is it 99%? It's going to make a big difference on what you're purchasing and how much you're willing to spend. So how much is there, that concentration or amount? So when we look at this, a box of donuts, we have a 1 part per dozen or 1 part per 12. So when we look at this, it's 1 pink sprinkled donut per a total of 12 donuts. So that 1 per X concept. And then similarly, we look at this. You have 1 penny of 100 cents that equates to $1, right? So 1 part per 100 or 1 cent of a percentage. So when we start looking into the lab and how we define and how we analyze for, we start going into like parts per million. And so now we're looking at just how small we're really looking at when we're analyzing in a laboratory instrument. So we're really taking it to the next level. We're looking at 1 minute in 2,000 years, 1 penny in $10,000, or 1 inch in 16 miles. And now if we go even to 1,000 times less, we're not looking at 1 part per million, but 1 part per billion. So just to kind of do a comparison, this is a great slide. Instead of that 1 minute in 2,000 years, we're now looking at 1 second in 32 years, 1 penny in $10 million, or 1 inch in 16,000 miles. So it's 1,000 times less. So you can see just how small you're really starting to analyze for. And then if you go to where we're at now, we are now sampling PFAS, PFOA and PFAS levels at 1 part per trillion. So we are looking at 4 grains of sugar in an entire size Olympic swimming pool. So you can see just how small parts per trillion really is and what we are capable of analyzing for, and how it's just becoming more and more in terms of being able to analyze for something at that small of a quantity. So if we kind of put this all together, chemists use mass per volume to measure concentration. So when I was speaking of parts per million, they look at it in milligrams per liter. Parts per billion, they're looking at micrograms per liter. And then that parts per trillion that we were just talking about, where they sample for PFAS, is nanograms per liter. So it's just becoming more refined, more scientific, and just more that you're able to look at. And who knows, in another 20 years, it'll probably be, you know, parts per quadrillion or something even more at a smaller scale. So water quality testing, what is the most important water quality test? I wish I could do a raise of hands here, but just for that answer, it is the coliform family. And right here, it shows total chloroform. There's a lot of coliform bacteria, and then there's subsets. So you're looking at a subset, which is fecal coliform, and then another subset that is E. coli. And how we test for that is by using the ColAlert incubator that's set at 35 degrees Celsius, which equals 95 degrees Fahrenheit. And you might ask, why? Well, it's because total coliforms are a broad group of bacteria, and they really do grow best at human body temperature. And what's your body temperature? Generally around that 95 degrees Fahrenheit. So if there is a potential for any type of bacteriological growth, the best way to encourage that growth is to mimic what you would naturally see in our human gut. So if it was negative for total chloroforms, it would generally be like clear or a very light tint that you can see on the screen here. If it's positive, it really is a darker yellow color. If it does test positive for total chloroforms, you do want to go to that next step, and that would be placing it under a UV light. And that UV light, if it turns blue, that would be the indicator that it is positive for E. coli. So microbiological contamination. So we're looking at bacterial and then viral. So we're really looking at the biological contaminants or organisms that are in drinking water. So things that are, pathogenic or disease causing. Usually pathogens are found again in the intestinal tract of warm-blooded animals, so inside our gut. So you're looking at like bacteria, viruses, protozoa, and parasites. And so this is, again, why we collect those total chloroform samples weekly, and then we have them analyzed in our internal lab. And then we're able to use that chlorine or chloramine as a primary disinfectant to prevent that bacteriological contamination or growth of pathogens. And then also chlorine will help prevent such contaminants as E. coli, Legionella, and Giardia. And then it will inactivate and destroy viruses such as hepatitis, polio, norovirus, and rotavirus. So it really is just a general great safeguard for public health. Chlorine is essential for making sure that we do not have these type of diseases in our drinking water. And just to kind of reiterate that and to go more into depth, look at the death rate for typhoid fever in the United States between 1900 and 1960. So you can see that there were deaths in the early 1900s, and then probably in about 1908, you can see that people started to use chlorine and the chlorination process began. And as time went through and as people started to learn and as it started to become regulated, more water agencies or water purveyors started to use chlorine. And by 1950, it was more or less eradicated. So it really is telling to show how important having that good chlorine residual within that system is. And so this picture shows how turbidity is measured. So we're looking at an instrument that works through by shining a light beam through a liquid sample and using a detector to measure how much of that light is scattered, absorbed, or blocked by suspended particles. So the amount scattered light corresponds directly to the cloudiness and concentration of the particles in the water. And I do have a couple standards here. Might be a little hard to see, but the one that I'm holding on my left hand, so right here, that has 800 NTUs. So you can see it is very cloudy. The one in my right hand, or the one a little bit higher here, that one is 10 NTUs. And all that means is that's not as cloudy or high with particles. So we do treat our water to less than 0.2 NTUs. And this is an example of our turbidimeter that we have in our laboratory. So let's talk a little bit about PFAS. What do you need to analyze per and polyfluoroalkyl substances, or PFAS? It takes a very sophisticated instrument to analyze down to that parts per trillion that we were just talking about. And then we are able and fortunate that we have a lab in-house, and they are certified, so we are able to analyze for PFAS, which also saves time and money. And we are certified through the Environmental Laboratory Accreditation Program, or what we would call ELAP. So tackling PFAS contamination. So there is a lot on this screen, kind of just where we're going with this. Approximately, or during 2013, 2015, the US EPA required water agencies to sample for certain PFAS constituents as part of the Unregulated Contaminant Monitoring Rule, or UCMR, for PFAS sampling. And then from that, they start to decide if there's any rules or regulations that need to come from that data that they've received from the United States, from all the information that they've pulled. So the California Division of Drinking Water, or DDW, in 2018 established the first set of regulations to PFAS levels in drinking water. And then the US EPA in 2024 started to create regulations for PFAS that established legally enforceable levels in drinking water. So it became California and other states, and then the US EPA started making overall enforcements for the United States. And then back to California in 2025, they initiated the process to revise notification and response levels for PFAS. So there's going to be more coming, more rules, more regulations as more information is found and as more PFAS chemicals are detected. Just high level PFAS sources, it's really anywhere that's in your nonstick cookware, shampoos, firefighting foam, your rain jackets. It's been around for decades. It's really just becoming, like I said, in the last decade or so, where that we're noticing it in drinking water. Fortunately, SCV Water has been taking a very proactive approach. We were the first ion exchange treatment for PFAS in the state of California. As of right now, we currently have four PFAS treatment facilities online, and we have numerous PFAS treatment projects in planning, design, and in construction. And then just again, we do in-house testing for PFAS, and we are accepted through the California eLab. So this is a great picture of our 4 treatment facilities. We have our N wells, and that comprises of 3 wells, N, N7, and N8, and that's over by the ball field. It has a combined flow capacity of 6,250 gallons per minute. We have our Valley Center well, which is a single well and has a flow capacity of 1,200 gallons per minute. And then we have our Hamby and Santa Clara, so a total of 2 wells that have a combined flow of 2,000 gallons per minute. And then our TNU wells, which is 3 wells that has a combined flow capacity of 2,000 gallons per minute. So overall, this brought back 11,450 gallons per minute of restored groundwater through ion exchange treatment to successfully remove PFAS. And like I mentioned, we're only going to be doing more of these treatment facilities. So regulatory compliance and reporting. I cannot stress how many reports that we do. All of our reports are submitted to DDW. We do monthly reports for bacteriological, general physical, nitrification. That's just a few of them. Quarterly reports, we have disinfectant byproducts. So just as I mentioned earlier, disinfectant residuals. We have annual reports such as electronic annual reports, or EARs. We have triennial reports for public health goals. And we even have reports for you, our customer. They are called the Consumer Confidence Report, and they are required by DDW for us to complete and distribute annually by June 30th of every year. Starting next year in 2027, we will be producing them twice a year. They are available in digital and hard copy, in English and in Spanish. So if you did want a hard copy, please reach out to our customer care department. They would be more than happy to provide you a copy for you to read at home. If you are okay with online, please check out our website and you can look at all of our copies from like the last 5 years. And then for customer notification, we did print notification in our water bill and sent via email. And then we have numerous media announcements. And just a little shout out for our public relations department. They do a phenomenal job with making good faith efforts. So they'll post on our website with our legal ads, press releases. We have media stories. We have an e-newsletter called Water Currents, social media posts, and we also have a hard copy at our libraries. So our CCR is not just what we want to put in, it's what we can provide that also requires information per DDW. So we have general water quality information that will provide water sources. So our groundwater and surface water, any new water sources that may have been placed online, that would be part of our drinking water source assessment, water quality information, board meetings, and contact information. And then we have the technical water quality information, and those would be like our primary drinking water standards, so anything that would be a health-based, maximum contaminant levels or MCLs, total chloroform, treatment plant turbidity, if we have lead and copper at any of the schools or any lead and copper in consumer taps. So secondary drinking water standards, the unregulated contaminants. So all that information and part of that is required as part of our CCR. Also required is where our water comes from. So this goes over our groundwater, our import water, which is the Castaic Lake, recycled water, and any stored water or banked water that we may have in the Bakersfield area. So water quality data, this might be a little hard to see, but just kind of a general overview. This will provide the list of constituents with any detectable levels that we have in our system. We do break it up with our surface water treatment plants and then our groundwater. And then we have a separate one for our District 36, which serves our Val Verde area. And the reason they are on here is we do serve water to them when needed. So common water quality calls. These are some of the water quality calls that we get very often. So is my water hard? Does it mean it's unsafe? The answer is no, absolutely not. All it means is that you have a higher quantity of calcium and magnesium. And think about it this way, a lot of times people want higher or some minerals and they use dietary supplements. It is in our drinking water. It is not a health concern. More or less, it becomes more of an aesthetic issue. Most people don't like spots on the dishes or deposits on the faucet, but it is aesthetics and it is nothing to be concerned about in terms of health. Why is my water cloudy? So a lot of times this is actually by entrained air. And so this can happen when a groundwater well is pumping. It may not always capture all the water. It could bring up air. And then sometimes that air doesn't always dissipate when it's in our main lines. So it will come into your house. And when you turn on your faucet, it'll turn on. And sometimes you'll see this cloudy water in this picture here. And if you just put it in a glass cup, let it sit for a minute, a lot of times you'll just see it'll start dissipating up. So the cloudy water will start rising until it clears up. So again, it's not a health concern. It is just air trapped in that water. So why is there a rotten egg odor in my water? This is generally caused by a drain. Underneath your drain, you have a P-trap, or it looks like a U or a J shape. And a lot of times that's supposed to be filled with water. And what it does is it prevents that sewer odor from coming back up into the house. So when you turn on that faucet, a lot of times that water is going to come down. It can actually bring those gases up at that same time. So I would recommend taking the same thing, taking that glass cup, filling it up, turn off your water, and then leave that room or just step away from that sink and smell the water itself and see if it's that same odor. It probably isn't. It's probably from that sewer line that's coming up. You may just need to unclog that. A lot of times something as easy as like taking that line, that snake line, and unclogging that will take care of that odor. Why is my water discolored? So a lot of calls vary. If you tend to get a yellow tint, I would ask, do you have a water softener? And if you do have a water softener, when was the last time it was changed out? A lot of times those canisters can be outside on their trucks, and when they come in, they may already have kind of a chemical reaction going on in there. And so when it hooks up, you might see that yellow tint. So I would recommend going to that yellow or going to the canister, seeing when did that last canister get serviced. If it was that date, that might be a good indicator. You can also push that bypass button that's on there and then do another flush and see if that water clears up. And if it is, then that would potentially be from that water softener. If you see colors that are more of a brown, that could be a hit hydrant or suddenly an open or close of a valve or a hydrant. So best to see if there's any type of internal flushing you can do, but if it is brown throughout the whole house, I would recommend giving water quality a call. And then that way we could go out there and do an assessment and see what's going on. If you happen to see a reddish color, that's usually caused by galvanized plumbing. And so that would be an internal plumbing issue. And not on here, but I would recommend if you saw a green color, I would make note if you had copper plumbing or not. Because a lot of times if you see green leaching, that could be the leaching from that copper pipe. Why does my water have a chlorine or a chemical smell? As I kind of mentioned earlier, we generally disinfect with a chloramine, which is a chlorine and ammonia combined to a 5-to-1 ratio. But sometimes we do need to use a free chlorine, more specifically at some of our tanks. And it does have a stronger odor. But the reasons why we're doing it is because we want to make sure we have that primary disinfectant. We want to make sure that we are safeguarding that water throughout our entire distribution system. And we are ready for any questions that you may have.
Feel free to drop those questions in the Q&A or in the chat, and we will do our best to answer them. And if you have a question, but you don't want to ask it right now, you can always shoot us an email at waterquality@scvwa.org, which I just dropped in the chat. Are we currently using groundwater in SCV? From Anna.
Yes, we are. We have, like I just said, numerous wells that are treated for PFAS, and those treatment facilities will run continuously, so 24/7. And then we have other treatment facilities online for other contaminants that also run 24/7. And then we do have other wells that will run infrequently depending on the supply versus demand. So obviously, if it's summertime, we tend to need more wells running just because there's a higher demand for water versus when it's raining in the winter where we could back off some of those wells.
Glad to have you, Mark. Thanks for joining us. Okay, I will keep this going for a couple more minutes just in case some people want to take some time to think of questions.
Well, I'd just like to say thank you everyone for joining today. I hope you learned something new. And if you do have any questions, feel free to drop us an email later and I'll be happy to respond to you.
And is asking if we should have additional filtration at home.
It is not necessary. All of the water that we supply meets and exceeds any type of state or federal regulations. However, it is up to you if you chose to do any type of water softener or any other type of filtration that you would feel comfortable with.
Any last questions? So dropping in the chat just because I noticed we had some questions about where our water comes from. I'm linking to our website where you can see all of our water sources and learn more about that there. Okay, And if we don't have any more questions, I am going to wrap things up. Thank you so much, Jenny, for your wonderful presentation. It was very educational. Thank you all for joining us. We hope you learned a lot. And if you want to review the presentation, we will be posting this on the website before the end of the week, where you can rewatch everything. If you have further questions, again, you can email us at waterquality@scvwa.org, and we will get back to you. I will release you, and I hope you have a wonderful rest of your night. Thank you, everyone.
Thank you.
Oh, wait. How much of PFAS are eliminated? Just saw that. Sorry, everyone. How much of PFAS are eliminated that came in?
Sorry, repeat that?
Someone
How
asked
much?
how much of the PFAS are eliminated. I'm assuming through the treatment plants.
So, okay, great question. For the ion exchange treatment facility, our goal, our operational goal is to have it below non-detect. So what is detectable within the laboratory instrument? Which is, I believe, what, 2 parts per trillion.
Thanks to your scale presentations earlier, we know that that is quite a small amount.
Yes. So we can never quantifiably just say that there's 0, but we can only know as confidently as what a laboratory instrument can test for. And so that would be below 2 parts per trillion.
Any other questions? Okay, thank you, everyone. Have a wonderful rest of your nights. Again, the presentation will be posted online before the end of the week. Have a wonderful evening.
You too. Thank you.
Take care.